Bismillahirrahmanirrahim. The topic of our today's lecture is kinematics of fluid flow. Up till now, we have studied the effect of force on the liquid at rest. Now we will study the motion on liquids without any reference to the force causing motion. It means that this lecture deals with the study of velocity and acceleration of the liquid particles without taking any consideration of any force or energy. Before going into the detail, first I will explain some flow types. The flow can be categorized into different ways, like according to compressibility, according to uh, shape of the object, or whether it is flowing under gravity or pressurized, or it can be classified according to different numbers like Froude number, Reynolds number, Mach number, Euler number, etc. So these number will be discussed in detail in future lectures. And after explaining these flow types, we will discuss the continuity equation and we will solve related numerical. And then in the future lecture, we will discuss Bernoulli's theorem and its application in the in real life. And we will discuss, and then we will solve some numericals related to Bernoulli equation. First, we will discuss the equation on ideal fluid, and then we will discuss the equation on real fluid. So let's start our today's lecture with different types of flow. So first type is according to compressibility, like flow is either compressible or it is incompressible. What is the meaning of compressible flow? A flow in which the volume of fluid and its density changes during the flow is compressible flow, and if the volume and especially the density if remain constant during the flow, then it is incompressible flow. So the gases are an example of compressible flow, while the liquids are generally considered to have incompressible flows as their density do not change during the flow. The next flow type is according to steady and unsteady flow. So what is a steady flow? A flow in which fluid characteristics like velocity, pressure, density and discharge, etc. at any point in a stream remains constant with respect to time, but the conditions may be different at different points is called steady flow. And if these flow conditions like velocity, pressure, density, discharge, etc. at any point in a stream changes with respect to time, then it is called unsteady flow. It can be further explained like by drawing a cross section. See if this is a cross section of a stream at different points. I label these cross sections as 1, 2, and 3. If we measure these characteristics like velocity or discharge, etc., at section 1 after different intervals, like after 10 seconds, 20 seconds, 30 seconds, or after a minute, then if these characteristics do not change, and then it is a steady flow. But these conditions at point 1 may be different from point 2 or from point 3, but uh, at a particular point these should not change with respect to time, then this is a steady flow, otherwise this is an unsteady flow. So example of a steady flow is a flow through a prismatic or non-prismatic conduit at a constant flow rate. And what is prismatic conduit? A conduit which has constant size or shape is known as a prismatic conduit. So steady flow can be in a prismatic, can exist in a prismatic channel, or it can also exist in non-prismatic channel, provided the condition described here is fulfilled. And what is the example of unsteady flow? An unsteady flow example is the flow in a pipe, like whose valve is being opened or closed gradually. So if this is a pipe and there is a valve at the start, and there is a valve at the start which you open or close gradually, then the flow conditions like discharge or velocity, etc., will change at this point. For example, at point 1, if the valve is being closed gradually, then the velocity will change with respect to time at this particular point. Then this is an example of unsteady flow. Now let's discuss another flow type, which is uniform and non-uniform flow. So what is a uniform flow? If the flow velocity at a given instant of time does not change within a given length of pipe or channel, then the flow is called uniform flow. And if the flow velocity at a given instant of time changes within a given length of pipe or channel, then the flow is called a non-uniform flow. So it can be also explained with the help of drawing a cross section. For example, this is a cross section of a pipe or a channel. So if these are different points in a cross section and we measure the velocity at all these points at a particular time, for example after 10 seconds the velocity remains same at all these points, then it is a uniform flow. Then we measure the reading after, let's say, 30 seconds, and the flow velocity at same at all these points, point 1, 2 and 3, then it is a uniform flow. The reading may be different at these two times. So it is irrespective of the time, it depends upon the distance. So within a given length at a particular instant, if the velocity remains constant, then it is a uniform flow, otherwise it is a non-uniform flow. So some examples of a uniform, an example of a uniform flow is flow through a straight prismatic conduit. It means that flow through a straight pipe of constant diameter is an example of uniform flow. That is, if it is a straight pipe and it is of a constant diameter, then at every point the uh, then at every point the flow velocity will remain the same. Because if discharge is constant from the source and the area is constant, then the velocity will not change at any of these points. So this is an example of uniform flow. And the example of non-uniform flow is flow through a non-prismatic conduit or flow around a uniform diameter pipe, bend, etc. is an example of non-uniform flow.